Okay, so in this problem, we're told that for every x, for all x, where x is not equal to a -3, notice that when x equals -3, the denominator here will be 0, and therefore x cannot be -3. So this is just sort of like something that it has to be told ahead of time. It's a value given to you, or something that is sort of like a warning, that to be aware that x cannot equal -3. So for all x's that are not equal to -3, they want you to take this expression, and you know that expression equals to that expression, and they want you to find this value of b here. So this is what we're looking for. This is the unknown. Now we were asked to find b. So how we're going to find b? Well, you notice that this looks like, let me just write it on this side. It looks sort of like something like this. We have an unknown that is on the top. We have something on the denominator, say a 2, and the answer somehow is like 3. Let's say that we have this. This is just an example. I usually like to explain things a little bit simple and then generalize it to something bigger, just like that. So now if I'm solving for x here, the whole idea here is that we can use the multiplication principle for solving equations. You notice that here we have x and we're dividing it by 2, so we have an opposite operation of multiplication, which is the multiplication principle, which is if you divide a number to a variable, the opposite will be multiplying by that number. So we multiply both sides by that denominator of that number, and at the end 2 goes into 2 once, so 1 times x is x, and 3 times 2 is 6. So the answer for x is 6, because 6 divided by 2 is 3. So you notice that if we have a number, we're dividing it by some number, some constant. If you want to find that unknown number, you just multiply both sides by the denominator. So the idea is the same here, where we have the variable on the numerator, and we want to find that number, that unknown number. But we know that we have this denominator here and something on the other side of the equal sign. So to solve for the b, we should multiply both sides by x plus 3. So I'm gonna write it over here, I guess. Let me see. We have 2x squared plus bx plus 3, and all this is being divided by x plus 3. The answer is supposed to be 2x plus 1. So remember, we're taking this expression and we're going to multiply by the denominator on both sides, x plus 3, and do the same thing to this expression. We're going to multiply this by x plus 3, so I write it this way. Now you notice that this method is the same exact thing as just cross multiplying. Just putting this over 1 and cross multiplying. So notice that these two terms, because they're being multiplied, you can reduce. X plus 3 goes into x plus 3 once. So then we're left with 1 times this entire trinomial, which gives us 2x squared. That's an x. Plus bx plus 3 equals to this product here. Now, we gotta be careful with this product. We're multiplying two binomials. So when you multiply the binomials, you want to make sure that you distribute. So we're gonna multiply the first term times the first term. That gives us the 2x squared. And then we're gonna multiply the first term times the second term. So that's gonna give us a positive 6x. Now I'm gonna have to change this around because it looks like a 1. So let me try it again. Let me make sure that this looks good. So we have this number. I'm gonna put a 2 here. Alright, that's better. Now I just finished multiplying the 2x times both terms over here. Now it's time for the positive 1 to multiply it over to this side. So positive 1 times x is a positive 1x, and a positive 1 times a positive 3 gives us a positive 3. So you notice that we have two like terms here, so it might be good to combine those two like terms. So here we're going to end up with 2x squared. I'm going to keep that the same. I just bring it right down. And here we have 6x plus 1x. So because they're like terms, we're going to add. They have the same signs. That gives us a 7x. Bring down the positive 3. So we end up getting on the right side of the equal sign, we have this trinomial. But you notice that on the left side of the equal sign, nothing changes. Everything stays the same. Now, what we want to do is we're looking for b. So one way you can do it, I think the simplest way, will be just to look at the two things that we have left here. You notice that the 2x squared and the 2x squared are the same. They're supposed to be, the two sides are supposed to be equal to each other. The 3 and the 3 are exactly the same. So in order for this trinomial on the right side to be equal to the trinomial on the left, then the only thing that makes a difference here is that b number. So the question is, what should that b number be, so that at the end you get this entire trinomial to be exactly the same as that trinomial? Well, then therefore it looks like the b must be exactly the same as the 7, because you notice that the b is right in front of the x, just like the 7 is right in front of the x. So therefore b must equal to 7. So this is our final answer for the problem. We just found b. Now if you were to use a different method, the other method of doing it is just solving. So you just subtract 3 on both sides, and you notice that the 3's cancel. Subtract 2x squared on both sides, and they'll cancel also. So at the end of the day, you're just going to end up with bx equals 7x, and if you divide by x on both sides, you end up getting b. So the main goal here is to find that b, and we just did. So remember, every single time you gotta look for b, all you gotta do is really look at the place of b and see what number is taking the place of b on the other side, and you match them. All right, good luck with this.